So make a start. If people continue to join us, that's fine. So good afternoon, everybody. This is the fourth in the little series of talks. And this time I'd like to talk a little about ETCS levels and transitions between levels in ETCS. So it's all about getting the level right. So let's just refresh our memory of ETCS levels. I'm sure quite a lot of you know these anyway, but ETCS has got three core levels. Level 1, which is designed for the movement authority to be issued by Belize's. There are some options around using Euroloops and radio infill, but principally the movement authority is issued by the Belize in the forefoot, and it is referenced to that Belize. Level 2, which is the UK preferred level, where the movement authorities are issued over the Euroradio, the radio link, with the advantage that movement authorities can be updated at any time, can be withdrawn, emergency messages can be sent. Level 2 can be used with line-side signals or not. So Cambrian is without line-side signals, Thameslink and 0 to 12 have line-side signals. Level 3 is the next stage on from level 2. The key difference being that the trains are now monitoring the end of the train, the rear of the train, reporting that the train is in one piece, so that you can use the reports received from the train to know the location of the train and hence where the rest of the line is clear. Level 3 is the enabler for moving block in ETCS, where each train is following the train ahead rather than waiting for fixed train detection sections to go clear. There are some other levels available within ETCS. Level 0, where there are no trackside systems and effectively there is no protection. We are planning in the UK to use that for possession operations only. One slight exception for those of you familiar with Cambrian is that on the Cambrian, level 0 is used for the operation of the trains when they're not on the Cambrian ETCS line. It's a slightly different use of the levels, but that was driven by the earlier baseline of the ETCS system. So if you go to Cambrian and you see a train at Shrewsbury and the driver selecting level 0, that's okay. It's just the way those trains work. And the last level is NTC, National Train Control, and this enables a Class B system. So ETCS is known as Class A. It is the gold standard. Class B is everything else. And there can be more than one Class B system installed on a train or on a trackside. So there are many level NTCs. Currently, there are about 41, 42 of them. And they cover systems such as TPWS, TVM, such as on HS1, CBTC, as is being used for Crossrail, and all the other European legacy train protection systems. So the question for the driver is which level to choose. And without any other information, the DMI on the train will display a whole plethora of levels for the driver to choose from. And of course, that means there is a chance that the driver will get it wrong. And getting it wrong could have consequences because there may not be any protection for the train movements going ahead. And the reason it is going to go wrong is because we won't have compatibility between the trackside and the onboard. So the trackside may be transmitting information to tell the train to stop, but because the train is in the wrong level, it will ignore that information. both the railway undertakings and the infrastructure managers are required under the Railway Safety Regulations 1999 that in normal operation, trains and trackside are equipped with an approved train protection system. Those regulations arose from the two accidents outside Paddington at Southall and Ladbroke Grove, and it is the basis for TPWS to have been introduced. The levels of ETCS are designed to provide compatibility between the onboard and the trackside. So if you're operating with ETCS, you will have compatibility. If you're not operating in ETCS, then your Class B system needs to provide that compatibility. So how are we going to make sure that the onboard and the trackside are compatible? Well, the first stage of the process is for the trackside to declare to the onboards what levels are supported.
Can you hear me now?
Hello, Mark. So the trackside instructs tells the onboard what levels are supported in a particular area, and then the onboard can make a decision. When the onboard is trying to decide on a level, it's often explained to people that the trackside instructs the onboard to change level. That's not strictly true. Some configurations, it is the effect, but actually it is a more complicated process than that. And we're going to have a little look at it now. So the trackside has stated which levels are supported for the onboard to select from. And obviously for compatibility, the onboard has to be able to work in the level that it selects from the list that the trackside has sent. And the way this is managed is through what is known as a table of priorities. Now, for those of you who've been to these sessions in the last few weeks, you'll know we need to go back to subset 26. Subset 26 is the system requirement specification for ETCS, and it's where we can find all the information about how the onboard is expected to perform. And in this case, it actually gives us an instruction about the trackside. In chapter 5 of subset 26, it tells us that when we announce or instruct the chain to change levels through a level transition order, we include within the message the supported levels using a table of priority. And even if there is only one level in that table, it is still regarded as a table of priority. A little bit like Belize groups can actually consist just of one Belize. So the trackside, as part of the level transition announcements and level transition order, announces the priority table. And now we get a requirement on the onboard that having received that table of priority from the trackside, the onboard selects the level with the highest priority available for use by the onboard equipment. So the trackside says, I can support you if you work in these levels. The onboard is now expected to select one which it can work in from that list. So what does available for use mean? Well, again, subset 26 gives us some advice. For level 2 or 3 to be available for use, it first has to be configured on board. When the supplier of the ETCS onboard supplies the ETCS and it is then installed within a train, part of the configuration is to say which levels can be operated using that ETCS onboard equipment. So providing level 2 or 3 is configured and at least one of the data modems is available, then that level is considered available for use, irrespective of whether the mobile terminal is actually connected to a radio network or not. For level NTC, it's a bit harder. The ETCS doesn't really recognize level NTC. It looks for an external subsystem to tell it that that particular level NTC is available. So in fact, the level NTCs are also configured on board as a list, and whenever the system is testing to see if a level is available, it will go out to an external module and ask it whether it is in working state or not. And there's a whole load of extra details about that. Level 0 and level 1 are always considered to be available for use. Now that makes an interesting question, because there are some ETCS onboards which have specifically been configured to not allow level 0 or level 1 in certain circumstances, or to put an extra step in the process before you can select level 0. So are they compatible with the specifications? A very interesting question. Ask your NOBO. So how does the trackside convey this information? Well, the first thing is it can use a level transition order, packet 41, or it could use a conditional level transition order, packet 46, or it can send a level transition announcement, packet 41. Now you'll notice that the same packet can be used for the level transition order and the level transition announcement. So let's have a look at that packet and try and understand how it works. Packets are defined in chapter 7 of subset 26. So again, we're dotting around the documents to find things, and there we can find a level transition order described with all the fields. The priority table is described in two parts. There's always a level that is in the table. That's the first M underscore level transition. And if that was level NTC, then there is a qualifier of NID NTC to say which type of level NTC is available, whether it's TPWS or TVM or CPTC, etc. The second part of the priority table is an option to repeat multiple levels. N underscore ITER, iteration, can be set to 0. If it's set to 0, you don't include any more levels. Otherwise, you can record as many levels as is practical. So the priority table is those two parts, and the order is the first entry is the top priority, and then the entries in the second box form the subsequent priority entries. If we are talking about a level transition order, then it happens immediately. So the distance to where it occurs, D underscore level transition, is set to 0. For an announcement, a distance is put in there. And because we're talking about a distance, we have a scaling factor to tell the system whether we're dealing in multiples of 10 centimeters, 1 meter, or 10 meters. If we announce the level in advance, we can also offer the driver the chance to acknowledge the future change of level before they get to the transition border. And that is covered by L underscore AC level TR. These acronyms trip off the tongue, don't they? And that is how far before the transition border the onboard should offer the driver the chance to acknowledge the future change to a different level. That can be set to 0, which means that the driver does not get the invitation to acknowledge the level transition until after the border into the new level. So the trackside transition orders that we've looked at are a level transition order, packet 41, and in that configuration it happens immediately with the train adopting the highest compatible level in the table. Or we can have a conditional level transition order, packet 46. That also happens immediately or is actioned immediately. However, now the onboard will consider whether the current level is listed in the future priority table. If it is in the priority table, it will remain in that level. It won't go to the highest priority. However, if it is in a level which isn't listed, then it will apply the conditional level transition order as if it was a level transition order. And in a moment or two, I'll show you how that is implemented in the onboard. And then packet 41 can be configured to have an offset distance, so that becomes the level transition announcement. The same packet says that in a certain distance, this level transition will occur. So let's have a look at how the priorities are applied. So let's start with a train operating in level NTC. And within that level NTC, it is operating with a specific Class B system, which is TPWS, and that is identified as having a value of NID_NTC equal to 20. That has been allocated at the European level as representing TPWS. The train receives a level transition order, and within that, there are 3 available levels in priority order. The first level is level 3, then level 2, and then level 0. The train is also aware what levels are available in the onboard. And here they're listed, level 0, level 1, because they're always available, level 2, because the train has got an active data modem, level NTC, NID-NTC 20, which is TPWS, and also a special level NTC, NID-NTC 21, which is also using the TPWS Class B system, but is specifically for drivers who have not yet been passed as competent to operate in ETCS. We'll come to see how that is used in a minute or two. So our train is in level NTC and it receives the LTO and it will start at the top of the priority table. It will say, okay, level 3 is the first priority. Is level 3 available on board? And in this case, it is not available, so it'll be discounted. The onboard will now look at the next level in the priority table, in this case level 2, and because level 2 is available in the onboard list, the result will be that the train transitions to level 2. So though the level transition order was to go to level 3 or 2 or 0, because of the train checking what it supports, it actually results in a transition to level 2. So let's look at how that would be affected if we use a conditional level transition order. So in this case, the conditional level transition order received is still level 3, level 2, and then it has our special UK NID NTC 21 level, and then level 0. The train is currently operating in NID NTC 20. And once again, it has the same available list. We go through the same process. First thing to check is NID NTC 20 in the list of priorities? No, so we need to apply the priority table. NID NTC, the second level is level 2. Level 2 is available on board, and hence the train will transition to level 2, exactly as if it was a level transition order. So why would we use a conditional level transition order? Well, let's consider the train being in NID NTC 21. So this is a specific UK application where some drivers have not yet been authorised to operate in ETCS. It's not on their international driving licence. And so they select at start of mission NID NTC 21 on the DMI, and the train is now operating in that level. Because that level is in the priority table and it's obviously available on board, the train remains in NID NTC 21. It will not change levels. So what this allows us to do is at an entry to an area of ETCS with line side signals and TPWS is for the driver's entry of the level to determine whether the train transitions to level 2 or remains with TPWS as the protection system. It's not uncommon for implementations to add conditional level transition orders around the railway to make sure that even if a driver tries to change levels, that they will only be able to select the levels that are applicable to the infrastructure, or if a train does manage to get out of the compatible levels, to get it back into them as quickly as possible. So those are level transition orders and conditional level transition orders. They make the train change level. But we also have the opportunity of sending announcements. What's the point? Well, a level transition order can be sent with an offset distance, and it's only the LTO. The CLTO, the conditional level transition order, cannot have that offset distance. And the purpose of doing this is to actually advise the driver that a level change is planned for the future. So when a level transition announcement is received, the onboard goes through the process we've just been looking at to identify a trackside supported level in priority order that is available on the train. And if that is different to the current level of the train, it will display an announcement icon to the driver. However, the information we supply to the driver is only partial. There is no display to the driver of how far it is before the transition will occur. It could be a kilometre away, it could be 10 kilometres away if we send the information very early. It is just to give the driver a warning. So why announce? Well, it does give the driver that time to recognise that they're approaching a place where ETCS is going to start or going to end. They are going to need to change their interaction with the train and take more or less responsibility for the safety of the movement. Another thing it does is to duplicate the transition order. Once the train has been told that the transition is going to occur in, say, 1 kilometre, when it considers it has travelled a kilometre, that transition will occur, even if it doesn't receive a transition order from a police group at the border. So it is a way of ensuring that the transition will definitely occur by giving us diverse communication. If you go from an area of TPWS to an area of only ETCS and your train does not transition, then you'll continue to operate with no signals potentially and no train protection. The driver is hopefully going to notice quite quickly and stop, but you have a safety hazard. And the way the hazard is normally managed with ETCS is to use a duplication of the information, either by duplicating the police group or by sending the information by two diverse means so that as long as one gets through, it will be actioned. Now, in the past, we've had a good rummage in subset 26, and you'll know that any message that the train receives has to go through some filters to decide whether we're going to process it. And the transmission and acceptance of level transition orders and conditional level transition orders is no different. A level transition order will be accepted by the onboard if it is received from a Belize group or from the RBC as a Euro radio message. However, a conditional level transition order will only be accepted if it comes from a Belize group. What this does mean is that you can announce a future level transition using the RBC. And that does mean you can select which trains will get that message and therefore which drivers will receive an indication on their DMI that an announcement of a future level transition. And we also have to consider what modes the information will be accepted and processed within. And some of the modes have conditions. So for instance, the condition 7 underneath shunt mode tells us that the transition order and conditional order will be accepted. However, they will not be actioned immediately. They'll be stored and processed later on. And in this case, it's when you leave shunt mode. So we need to always be looking at the different chapters to understand how the information will be used and processed. But providing we send the transition order by the right medium, we're in the right mode, then the level will change. So we're in our new level, ready to go. If we were in level NTC, we would have been in potentially System National SN mode. We've changed to level 2, SN isn't a valid mode. So the action of changing level often means that the mode has to change as well. So what mode will the onboard transition to? So if we think about level NTC, there are 3 valid modes we can be in: standby, System National, and shunting. If we transition to level 2 in standby, we stay in standby. There's no change. Standby is still a valid mode. Similarly, if we change to level 2 and we were in shunting, then we stay in shunting mode and the level transition order is stored for later processing. However, if we're in System National, we could change to full supervision, on-site, staff responsible, or we could trip. So let's have a look in Chapter 4 of Subset 26 to work out which mode we're going to go to. Now, some of you may recall having seen this wonderful diagram, which helps us to understand which modes you can change from and to, and what are the conditions for each of those changes. So we're starting in System National, which is down the bottom right with the red square around it. And we're interested in what happens when we change to a level and therefore System National is no longer available. What are the potential modes we could go to? Well, they're listed in the column above, highlighted in blue. And we're just going to pick out some of the key modes. So let's start with FS, full supervision, highlighted in purple, and on-site, the modes that have a movement authority associated with them. And the 2 purple boxes within the blue vertical line tell us that there are conditions 25 and 34 which dictate whether we go to FS or to OS. So to go to FS, we switch to levels 1, 2, or 3. We've got a movement authority and the track description stored on board, and No other mode is commanded by the information within the movement authority. So the normal transition would be to go from SN to FS, subject to having a movement authority. If, however, the mode profile is also stored, then you'll go to OS on site. So those two modes are available if we have a stored movement authority, FS or OS. What other modes are there? Well, staff responsible is a potential. And we go to staff responsible if there are a number of conditions, and they're 44 and 45. And for us, the lower one is important if we're going to level 2. So the driver has previously, before the transition, selected override. So the override function is active. No unconditional emergency stop message has been received. That's fine. And then the ETCS switches to level 2 or 3. And there's more information in the override procedure in chapter 5. So why this is important is that if we have a problem with the ETCS, then the driver can be instructed to stop on the approach to the transition at a signal. They will be issued with a written order dictated by the signaler. That will tell them they can then press the override control, and having done that, when they proceed, as soon as the train transitions, it will transition to staff responsible. If you didn't do if you haven't got a movement authority and you haven't selected the override, then the next option is to go to trip. And the key condition here is 39, that if the ETCS switches to level 1, 2, or 3, and there is no MA stored on board, the train will trip. And that's an undesirable action. So hence the use of SR with the override procedure using a written instruction. Now, I did mention transitioning in SH. When you go from NTC to level 2, the onboard stays in level NTC SH. So when does the onboard eventually transition to level 2? So the transition order is stored, the priority table is stored, and when you exit shunting or passive shunting, that is when the level transition order is actioned. The act of coming out of shunting will cause the train to check the priority order and to choose the most appropriate level. So if you remember, we started off saying that we could have a lot of levels displayed to the driver. Potentially levels 1, 2, 3, 0, and all of the supported level NTCs on the train. So how does the priority table and the available levels configured in the onboard influence that? Well, if we're in an ETCS only area, the driver would normally only be displayed with level 0 and level 2. If level 3 was available, that would be available as well. By having that restricted list of levels reduces the potential for error. If you're in an NTC only area, then the driver would just be offered level 0, TPWS and TPWS fixed. So TPWS is the normal level accepted by a driver who's been trained to operate in ETCS, whereas TPWS fixed is for those drivers who have not yet been authorized to drive in ETCS. Only 3 levels to choose from. Hopefully the driver will get that right. If, however, you're in an ETCS with signals area, then level 2 would also be available. The driver can now choose potentially to select level 2, TPWS fixed, and depending on the priority table, may also be able to select TPWS. Exactly what appears depends on your trackside configuration and what's available in the train. So let's have a look at what it looks like for the driver. And for those of you familiar with Cambrian, this is a little video from the Cambrian. It is an earlier version of the ETCS baselines, so some of the things are slightly different, but as we watch it through, we should see some of the steps in a transition. One key difference between baseline 2, which is the Cambrian, and baseline 3, is that in baseline 2, a lot of the information is displayed as text messages. In baseline 3, most things are icons rather than text. So leaving Shrewsbury, the driver on the Cambrian selects level 0 and TPWS AWS is active and the driver is operating in unfitted mode. This is a peculiarity of baseline 2. If it was a baseline 3 scheme, as it will be when we do the upgrades, the drivers will be operating in level NTC with TPWS active. As the train approaches the transition, the first thing is it reads a set of balises, and those balises are instructing the train what radio network to use. As the train proceeds, it then gets an instruction to connect to the relevant RBC, the radio block center, and that communication enables other things to happen, and that can take some time. So there is a typically 40-second allowance. And the session has now been opened. And in ETCS, the baseline 3, that will be illustrated by an icon appearing. There is time allowed for that session to establish before the announcement of the transition occurs. And in this case, it is sent by a set of balises. You'll see 4 balises which we're just approaching. 1, 2, 3, 4, which duplicate the message. And a message has appeared on the DMI to say that the train is now approaching an ETCS owned area and that the transition will be to level 2. That occurs when we read the transition order. And at that point, the DMI changes to display the planning area and other information to support the driver. So the transition, any transition from level NTC to level 2, normally there will be an announcement to the driver, various symbols will appear, and then the transition will occur, and the driver should be able to cope with that. So there are lots of ways that you can configure transitions. There are lots of ways that you can decide what to put in the priority tables. And one of the things that we have been working on for the last, well, a lot of years is something called a reference design. The whole idea being to be consistent about how we meet our business needs, make sure that our suppliers understand what we need. And that has to take account of all of the users and particularly our train driving colleagues. Anything we require has to be compliant to the subsets and it has to be supportable by all of the suppliers. And we've been through a series of cross-industry reviews, lots of hazard analysis to try and select the solution which appears to give the greatest consistency to the drivers, signalers, and the suppliers. And the aim is to minimize the need for the suppliers to develop bespoke solutions for each project, because we all know how expensive updating a product for another project can be. And the objective is that most transitions should be full speed, that in order to satisfy the railway safety regulations, the train should always have an active protection system or be in the process of enabling it, that we should manage driver workload, and we should have a consistent support for areas of ETCS without and with signals. And it's that last one that can often be a challenge, because what might be the optimal solution for going into an ETCS without signals area could be different from going into an ETCS with signals area. So we have to take account of the stages of the transition. There's the network registration. That's pretty standard. For GB, we only have one network. So in most cases, the ETCS onboard will already be registered with the correct network. But in case not, we can send a packet 45 from a Belize group to instruct the train which network to register with. This has no effect on what the driver sees. The next stage is to instruct the train to contact the RBC. And for this, we use packet 42. And within there, we include the details of the RBC that the ETCS onboard is to contact, typically including a telephone number. Packet 42 will start the onboard connecting to the RBC. The announcement, our packet 41, we've seen that before. That can be used to announce that we're approaching a level transition order, and that can be transmitted by a Belize group, as it is on Cambrian, or using the Euro radio, as it is on Thameslink and on 0 to 12 out of Paddington. When the transition occurs, the train has got to have a movement authority. So normally we issue the movement authority before the train gets to the transition border, and we'd use message 3, the movement authority message, to do that. And quite often that is combined with sending the announcement over the Euro radio. And lastly, packet 41 again, and that is sent as a Belize group message. The requirement in the subsets that the level transition order at the level border is sent by Belize group. So we need to put all those in, and we're going to start by looking at from session establishment onwards. So if we take a piece of railway, we're going from level NTC on the left-hand side to level ETCS, well, to an ETCS only area, let's say level 2, on the right-hand side. And beyond the red signal at the right, there is no TPWS. So we want to make sure that the trackside prevents a train that is not going to operate in ETCS going into that ETCS only area. If a driver did go past the signal into the ETCS only area, they'd have no train protection and they would not be getting any further information about the safety of the movement. So the design we came up with was to keep the border signal at danger. So here comes our train, and the first Belize group instructs it to establish a session. And so the Euro radio will beaver away in the background to contact the RBC, going through the session establishment process, which we looked at last time. After the train has moved on a short distance, it will get information back that the connection has been established. And this is the base level connection, which is now that we have got a radio link. And so an icon will be displayed to the driver, indicating that the session has now been established. With the core session in place, it's possible for the train now to start receiving messages. And in the design we have, the train will receive the level transition announcement and the movement authority. And that will result in the level transition announcement being displayed to the driver. So now the driver knows that the session has been established, and in a distance, which they'll probably know from their route knowledge, they will be transitioning to level 2. The Belize group that was used for session establishment or another Belize group can be used as the LRBG, the last relevant Belize group, and the movement authority and the track description will start from that Belize group. So even though the train is operating in level NTC, it will actually have stored on board a movement authority and track description for the remainder of the NTC area and into the ETCS area. However, at this point, the driver is still operating with the line side signals, As the train proceeds, it will acknowledge the fact it has received the movement authority. That acknowledgement can be used to trigger the clearing of the signals. And now the train driver has information to enable them to enter the ETCS area. And when they pass over the border, they will be asked to acknowledge the transition to level 2. That is how it is at the moment. There is actually a change request which has gone through the system, which for future onboards will not require that acknowledgement of going into level 2. Because you're going from one protection system to a better protection system in level 2, the agency has decided that it doesn't need to be acknowledged. So that is the sequence. If, however, the train didn't support level 2, it wouldn't be, even if it connected, it wouldn't be able to announce the transition to level 2. Then it would, the signal at the border would remain at danger. So the train would stop there and it would not be able to proceed. So it maintains that safety of always having a train protection system. When myself and my colleagues meet our friends from Europe, one of the comments is that you Brits are weird because they don't understand some of the things we do. For them, one of their best ways of getting towards ETCS is to use level 1 with signals, partly because their current ATP systems often involve having Belize groups placed at the signals. They have the line-side encoding units to convert the information from the aspect into telegrams, and they see it as a great stepping stone from their speed-based Class B system to an ETCS operation. For them, level 2 with signals is basically enabling trains which are fitted or not fitted to operate on the same line. And if the train is fitted, it is a presumption for them that the driver is fully trained and therefore the train operates in level 2. What they find is weird is what we have, where we have a train which is fitted with ETCS, able to operate in level 2, but for reasons they don't understand, our drivers are not authorized. And for them, that's just, don't do it. And because they are so used to having ETCS or cab signaling systems, they don't see any problem with having trained drivers for all of the fitted trains. So we in Britain have got a problem because if you look at Thameslink, there are significant hundreds of drivers who would need to be trained in ETCS and then maintain their competency. For Great Western, it's the same. And so we had to come up with a solution where the driver can tell the system that they are not authorized to operate in ETCS. So how did we look at doing that? Well, we looked at, could the driver's identity that they type into the system be used somehow to tell the system that this lady driver is authorized to operate in ETCS or not. Problem with that is that every train needs to have a database of all the drivers and you've got to keep it up to date. So when the driver is passed out, you've got to update every train, or you've got to, that doesn't really work. We thought, what about using the train running number or the head code? Well, that only works if the drivers, you always have a qualified driver on certain trains and not on other trains. Doesn't work. Another option was to introduce a extra switch or an extra key, an ability for the driver to somehow disable the ETCS, and the Class 700s have got a facility for the driver to operate a button on the DMI to say that ETCS is inhibited for this journey. So that's an option that was taken. And then the option we actually plumped for was to use that extra level NTC with NID NTC equals 21. What that means, though, is we now got to try and design our transition to going from level NTC to an ETCS with signals area and make that work similarly and equivalently to when the ETCS without signals. So we have our train, and this time our train is in what's known as TPWS fixed. NID NTC is 21. And the train, of course, is ETCS equipped, so it will respond to the messages coming from the trackside. At the session establishment, it will attempt to establish a session with the RBC. And it will form a connection, and the driver will see the connection icon. As it proceeds, it will make a position report. And that position report will be used by the RBC to trigger a message from the RBC to end the session. Basically, the fact the train has reported that it is NTC 21 means the driver is not authorized to operate in ETCS. Therefore, we don't need to keep the radio session, and the session will be ended and the icon will be blanked. And the driver will proceed in level NTC TPWS fixed, obeying the line side aspects. And at the border, we now have a conditional level transition order, enabling the train to remain in TPWS fixed. If the train was an ETCS fitted train and the driver was in TPWS normal, so they are competent, then the sequence of issuing a level transition announcement and the movement authority would have taken place in the same way. Now, I guess a lot of you were going, whew, that's a lot of signal sections. Where am I going to put that on my scheme plan? Well, yes, it does look like a lot of signal sections, but you can have junctions and things in the approach area. It can be managed, but there are locations where there is no room. And at some locations, trains actually start at the signal, which is the boundary with the ETCS area. There may be certain locations where there just aren't enough signal sections. So we have an option called level 1 launch. And what we do with level 1 launch is to use a Belize group at that first signal to tell the train to transition to level 1 and also to issue it with a temporary movement authority to enable it to start into the ETCS area, to make its connection, and then get the updates from the RBC. And that's all described in the reference design. If you're interested, then you can read up how that works. And we thought, because we'd worked this out ourselves, that we were all very clever. And then we went and told our friends in Europe that we've come up with this brilliant solution to use level 1 launch. And several of them said, yeah, we already do that. So, it's well worth going and finding out what our colleagues around Europe are doing. So we've had a look at entering ETCS. How do we get out? Well, leaving ETCS can technically be very simple. It's just a matter of stick down a Belize group that tells the train to transition, that level 2 is no longer available, select another level, which would be NTC. However, the problem is we need to think about our friend, the driver, and it's the drivability going out of ETCS that can be the biggest challenge. How do we provide them with the information they need in order to manage the train safely after the transition? Before the transition, ETCS does all the supervision. All of a sudden, all the information is taken away from them. The supervision is taken away from them. How do we keep that safe? So let's have a look at what the driver would see. And let's start by considering a situation where the transition, which is that board, the square board is where the actual transition occurs. and beyond that there are all green signals. So within the tab on the DMI, the driver is getting supervision information on the speed gauge, and in the planning area is getting information about how far they can travel. And in this instance, the movement authority is going into the NTC area by 3 signal sections. So what the driver would see on the DMI is a light blue area indicating the movement authority. At the end of that, a small gold flag with a 0 to indicate that's where they will need to stop in just under 4,000 meters. And the yellow line at the 2,000 meter is when the train believes they will need to start braking for that stopping location. So at this point, they are traveling. They can see they've got 2 kilometers to travel before they need to even think about braking. As the train proceeds, the announcement is sent to the train, so the driver gets on their DMI an indication that they will be entering level NTC at some point in the future. As they get closer, the display will be updated with the planning area, but still no need to start braking. And as they pass the transition, then they will enter level NTC. They will have to acknowledge it, which is shown by the yellow NTC icon, and the TPWS and AWS will start to be activated, and the AWS sunflower will be displayed to remind them they're now in an AWS TPWS area. And having acknowledged the transition of NTC and the given a bit of time for the AWS TPWS to wake up, they'll pass over the AWS magnet. In this case, it's showing clear, so the sunflower will go to black to illustrate that they're now operating on green signals, and the driver can now proceed at full line speed. So that seems to work quite well, gives the driver enough information. They not encouraged to slow down. They've got plenty of time to adjust to line side signals. What about if the first signal is green, but subsequent signals are cautions? Well, again, the driver is getting information. You can see that the planning area is identical to what it was for all greens, because the movement authority extends to the fourth signal in the NTC area, which was previously green but is now red, but it's still treated as the end of authority. Again, the driver gets the warning of NTC approaching, planning areas slowly updating. At the transition, they have to acknowledge NTC, and again, they get the AWS bell, black, they're going to a green signal. They've now got a signal section to prepare themselves before they encounter a first caution. So that all seems to work. What about now if the first signal is double yellow? What will the driver see? So now, because the red signal is one section closer, our planning area is now quite a bit shorter. We can see that it is indicating about 2,000 meters to the red signal, that the train thinks that in 1,000 meters, the driver needs to begin to reduce speed. So we're already beginning to provide some visual cues to the driver that they perhaps need to prepare themselves for a need to stop. As the train proceeds, again, level NTC is announced. And as they get closer, the planning area is getting shorter. They may be beginning to be aware of the need to reduce speed. At the transition, again, they have to accept it. They get the sunflower. Once they've accepted it, they're in level NTC. And now, of course, the first signal is double yellow, so they will get the AWS horn, and the sunflower will be returned after they've acknowledged the horn. So they're now operating in NTC and approaching a double yellow signal. Remember, from double yellow, they have full braking distance to the stop. So they haven't needed to reduce any speed, but they will need to react quite quickly in order to stop at the red signal. Moving on, you work out the next one is a single yellow. And this is where it begins to become quite difficult, because if you talk to drivers and their driving standards managers, at the moment they have rules about the speed they should be traveling at when they reach the single yellow. Unfortunately, those rules vary according to the type of train and the railway undertaking, but we need to try and help the driver obey those rules. So for a single yellow, then what we actually are proposing is the driver will see in their planning area that there is a reduction in speed, in this case to 60 kilometers an hour, before they actually get to the first line side, to the transition, and then they have the red signal at roughly 1,000 meters away. So they will be reducing their speed, and the speed gauge will be indicating them that the need to reduce the speed. As they proceed on, the planning area will be getting closer and closer. Level NTC will be announced, and they will actually be supervised down to the 60 before they actually get to the point of transition. Please excuse the DMI shots because they're just cut out of the DMI specs, so they're not perfect, but they give you an indication that the driver would be indicating they'll need to slow down. Just before the transition, they can also see that they've got to stop in a short distance, and the DMI will almost certainly be showing yellow, and it may even be giving them audible alarms to slow down. At the transition, the planning area disappears and they have to acknowledge the NTC. But hopefully now they're at a suitable speed so that once they're in NTC and read the AWS magnet with the horn and the sunflower, that they're now at a speed which is consistent with their professional driving. It's certainly a speed that they can comfortably stop at the red. Now, this is where it's quite hard for us signal engineers sometimes, is to think about how the driver reacts. Trained drivers are immensely good at doing their job. But if you think about driving on the motorway and then coming off onto a small road, how long does it take you to adjust to driving at different speeds, to getting information different ways, coping with pedestrians, traffic lights, things like that? We need to give the driver the support to do that. And part of it is to reduce the speed so they have more time to think about what they're seeing outside the cab. To complete the scenarios, what about when the first signal is red? And this is one of the contentious ones because you are approaching something that you're not perhaps expecting. So again, we're proposing that the driver will see in the planning area a speed, and in this case, it's a much lower speed, say 20 kilometers per hour. They can see the red signal as marked as about 600 meters away in the planning area here as being the naught. The DMI will be telling them they need to slow down. They will be braking already before they even get to the transition border. Level NTC will be announced. Again, the speed restriction is now getting closer. Their speed is being supervised down. And before they get to the transition, they'll be into an area where the speed is 20 kilometers an hour. Again, ignore the actual speed gauge there. Transition occurs, driver's got to acknowledge it. Now we're beginning to think about ergonomics. The driver, this is a distraction, so we need to think about where we place that so that the driver isn't distracted by acknowledging the change of level when actually they need to be concentrating on a red signal. Hence, trying to keep them to a very low speed when they transition out of NTC. Once they've acknowledged it, NTC is displayed, and then again, they'll get the AWS horn. But at 20 kilometers an hour, 15 miles an hour, they will have in the order of 400 meters from the transition point to the red signal. So plenty of time to stop. So that is the proposal. And you can see how complicated these things can be to think it through from the human's point of view. If you go to Europe, they'll say, yeah, but these are speed signals, not distance signals. So the speed that you come out of ETCS at is actually the speed that's displayed on the first signal aspect, because the aspect is a speed information. So it's much easier. So just to summarize, level transitions, they're all managed by the trackside supplying the table of supported levels. The trackside says what levels it is compatible with. The onboard then applies that table based on the levels which are available in the onboard. And the key thing is, however we design it, the trackside arrangement needs to support the driver. And consistency, drivability are one of the key things, because we don't want to encourage a driver to spad or find themselves in a difficult situation. And that's it for today's session. That's all. And of course, there is an opportunity to ask questions.